Okay, activity 1.3.3 in the calculus, we were supposed to find the uh, instantaneous velocity at 1 by finding s prime at 1 using the definition of the derivative. Now, the first one we did in class was fine. The second one I kind of went through a little bit fast, and I made a couple little errors that made it not real clear, and we got rushed at the end. So I want to go through and do these again. So I'm going to do the first one, which was the limit as h approaches 0 of s of a plus h, and they wanted to do it at 1. So I'm going to do s of 1 plus h minus s of 1 over h. Now, I'm going to work this out and then take the limit at the end. Otherwise, I have to write limit all the time in there. So I'm going to work out s of 1 plus h. So I got to put 1 plus h in for the t. So I got minus 16 times 1 plus h squared plus 16 times 1 plus h plus 32. All of that minus, now I got to figure out s of 1. So I got to put 1 in here. So I get negative 16 times 1 squared plus 16 times 1 plus 32. This is all over h. Now, 1 plus h squared, that's 1 plus h times 1 plus h, is 1 plus h, 2 h's plus h squared. So we got negative 16 times this. So I got negative 16 minus 32h minus 16h squared. 16 times this. 16 times that is plus 16 plus 16h plus 32 minus a minus 16 times 1. So that's minus 16. Oh, we'll just do this. That's minus 16, that's plus 16, so they cancel. So I got subtract 32 over h. These cancel. And these cancel. And so I have negative 32h plus 16h and negative 16h squared. So I got negative 16h squared minus 16h over h. H goes into both of those, and I get negative 16h minus 16 after I divide h into both of these. And I have this, and I'm supposed to find out what happens when h goes to 0. When h goes to 0, I don't have the divide by h anymore, so I can just put 0 in for h, and I get minus 16. So that's the speed, the derivative, the slope of the distance curve at 1 says it's going down at 16 feet per second, because this was in feet and seconds. And velocity, it's the change in the height over the change in time, so it's feet per second, and it's going down. Now, let's do it with the other definition. The limit as b approaches a, but a is going to, well, I'll put a, of f of b minus f of a over b minus a, but I'm going to write it with using this function above, so it's fb put in for all the t's. So that's going to be minus 16 times b squared plus 16b plus 32 minus, and in class I put in a, but a was supposed to be 1. So, and when we put 1 in, we did it up here, we got minus 32 over b minus 1. So I had a's in here, which made it look messy, but if I put the 1s in, it's not so bad. So the 32's cancel, and then I have negative 16 and a b, or 16 and a b can be taken out of both of those. So 16b times minus b plus 1. Well, this is the negative of this. If I pull a negative out, that makes that plus and that minus. Then these cancel, and I get this, and I'm supposed to find out what happens when b gets closer to a. A was 1, so we're trying to find the limit as b approaches 1, and that turns out to be minus 16. So this method was actually easier than this method if I had used the 1 in the spot for a. So I wanted to show you that.